In this video, we're going to talk more about Amazon DynamoDB. You may remember when we talk about NoSQL databases, we mentioned that Amazon DynamoDB is your fully managed option and one of the best options to go with. Amazon DynamoDB is Amazon's proprietary database designed to handle massive workloads with millisecond response time. It's very suitable when you need to scale seamlessly to millions of requests per second, store unstructured or semi-structured data, or build applications that require high availability and low latency, such as gaming backends, real-time bidding systems, IoT platforms, or serverless applications. DynamoDB itself is serverless, meaning that you can be confident that it automatically scales up and down and you don't need to worry about anything. In terms of backup and recovery, it provides you with on-demand backups and point-in-time restores so you can roll back if something goes sideways. If you need to go multi-region, global tables can keep data available across continents, and with DynamoDB Streams, every change can trigger downstream actions, which is great for serverless workflows. I also want to emphasize that DynamoDB is not just good for heavy workloads, but also a great choice if you simply need a straightforward key value store that's quick and easy to spin up, ready with just a few clicks, and it costs down to nearly $0 depending on your test cases. Alright, let's have a quick look on how DynamoDB works. At its core, DynamoDB is a collection of tables, and each table stores items as key value pairs. Now, please pay attention closely. This table is different from the tables in relational databases. In an RDBMS, tables require fixed schema and every row has to follow the same fixed column. But DynamoDB tables are schemaless, and instead of rows, you have items in the tables. In a relational database, every row has to follow the same set of columns, but in DynamoDB, each item can have different attributes without breaking the structure. One item can have name and email, while another item in the same table could have location and preferences, for example. So you don't have to redesign the whole table when your data changes, which makes it easier to adapt as your application grows. In DynamoDB tables, everything is organized by a primary key, which determines how the engine should store and find your items. The primary key can be either a simple key, which is just a partition key, or a composite key, which combines a partition key and a sort key. For now, I think it's good for you to know that the partition key decides which group your data belongs to, and the sort key organizes the items within that group. This way, DynamoDB can quickly find related items without scanning the entire table. Alright, now that we've got a solid grip on what DynamoDB is and where it shines, let's take it a step further. DynamoDB isn't just about storing and retrieving data. It comes with a bunch of powerful features that make it even more reliable, scalable, and flexible. DynamoDB lets you create backups anytime you need. With just a click or an API call, if anytime something goes wrong, you can restore your table to any point in time from the last 35 days. It's like having a rewind button for your data, making sure a mistake or accidental delete doesn't become a disaster. DynamoDB gives you two ways to handle capacity: on-demand and provisioned. In on-demand capacity mode, DynamoDB automatically provisions read and write throughput in real time based on your traffic patterns. This eliminates the need for capacity planning, and it is ideal for workloads with highly variable or unpredictable request volumes. On the other hand, in provisioned capacity mode with autoscaling, you define a baseline of read and write capacity, and autoscaling dynamically adjusts throughput as demand increases or decreases. This mode is optimal for workloads with predictable traffic patterns where tighter cost governance and consistent performance are required. TTLs are another feature of DynamoDB. TTL lets you set an expiration timer on your items. Once that time is up, DynamoDB will automatically delete that item. This is great for cleaning up temporary data like session tokens, cards, without writing extra cleanup code. If you need read performance even faster than the normal DynamoDB already provides, DAX or DynamoDB Accelerator adds an in-memory cache in front of your tables. This helps you get microsecond read latency, perfect for high-traffic apps that need lightning-fast lookups. If your users are spread across the globe, DynamoDB offers a feature called Global Tables, which is very beneficial for globally distributed applications. Global Tables provides the same behavior and nature of DynamoDB with multi-region active-active replication architecture. And finally, with DynamoDB Streams, every change in your table, like inserts, updates, or deletes, can trigger actions in real time. This is super handy for serverless workflows. For example, you could automatically send notifications, update the search index, or feed changes into analytics the moment data changes. Okay, we've covered the main concepts and key features of DynamoDB, from how it stores data and scales automatically to advanced capabilities. Feel free to explore DynamoDB on your own as well and get comfortable with the basics. But for now, please don't forget to subscribe to our YouTube channel, and I'll see you in the next video.